Okay, suppose we want to find the radical of a product. So, first of all, let's assume this is positive. We'll assume x and y are both positive. I guess technically they could both be negative and we could still take this, but let's assume that the roots of x and the roots of y both exist, which would imply that x and y are both positive. It also implies that a and b, or at least non-negative, it also implies that a and b are non-negative because, well, we're taking the radicals, which means we're taking the positive root, or at least the non-negative root in these cases. So everything is positive. What do we know? I want to find this. Well, if the square root of x is a, I know that a squared is x. And if the square root of y is b, I know that b squared is y. So, the square root of xy has to be the square root of a squared times b squared, which is this. And then by our rule, if we take the radical of a square, what do I get? I get the absolute value of AB, which we knew was positive to begin with because A and B came from radicals, which means they could not be negative. So, what do I get? I just showed that the radical of xy is AB, but A is a radical of x, and B is a radical of y. So we get our rule. I will note that we assume the following, that x and y are both non-negative numbers. Similarly, we can argue this as well. It doesn't just work for multiplication, it also works for division. However, here we have x greater than or equal to 0, and y is strictly bigger than 0. Why do I need y to be strictly bigger than 0? Well, just because I can't divide by 0. That would be bad. We're not allowing that, ever. So, these are our two rules, and I guess let's proceed to look at a few examples.